Alright, and this will be a good refresher here for you for multiplying polynomials. Key idea here would be that when we multiply variables, we're going to add their exponents. For example, x squared and x makes x cubed. Okay. Areas of product is written as the multiplication of the sides of an area model. Area of sum is written as the insides of the model. We've been goofing that up a lot lately here in some of our review questions. So what I'm saying is the outsides, okay, are the product. The insides are the sum. Okay, so that's something you want to keep in mind here. You have a couple options when you multiply these. Okay, you can make a generic rectangle. In this case, we'd have a 1 by 2 rectangle. It would look like this. You put your 1 term on the one side and your 3x minus 5 term on the 2 side. And then you'd multiply these boxes to determine what the area is. Or we can just use distributive property. But just remember, you got to distribute to everything. Okay? Same exact process, just two different models to set it up. So here we end up with 6x squared minus 10x. This one over here is a little bit more involved because we have a binomial and a trinomial. 2 terms bi, 3 terms tri. So here I would probably urge you to use the area model, a little bit more to keep track of for distributive property, so the area model probably works best. So again, this is a times table, so 2x and x squared is 2x cubed. All right, 5 and x squared is 5x squared. Let's fill each of these in. 2 and negative 4x, negative 8x. 5 and negative 4x is negative 20x. Sorry, that was an 8x squared. 2x and 7 is 14x. 7 and 5 is 35. I go through looking for my like terms. So there's a set, and there's a set, and then I write my answer. So the 2x cubed is by itself. It has no like terms. The negative 8x squared and the positive 5x squared make a negative 3x squared. The negative 20x and positive 14 makes negative 6x. And the 35 makes 35. So again, should be a good review of Unit 0, but in case you were out, now you have it again. So we're back to Jim. Or, no, I'm sorry, multiply these polynomials. Sorry about that, I'm getting ahead of myself. Example 3. Again, it's a binomial and a trinomial, so it's probably easiest to use that generic rectangle. All right, I am going to show distributive property though this time, just for those people that like that method. So 3x times x squared is 3x cubed. 3x times 2x is 6x squared. And 3x times negative 7 is negative 21x. All right, and then I'm going to distribute the second term here, which is the 2y. All right, so this looks a little different, but still the same. So 2y times x squared is 2x squared y. 2y times 2x is 4xy. 2y times negative 7 is negative 14y. And there are no like terms here because the x squared has the y with it and the x has the y with it. Therefore, they're not alike with those x squareds and x's. Just wanted to show you a little bit different look when you have more than one variable, what could happen. Now we're back to Jim. He wants to know how much grass fertilizer he needs for his yard. Find the area of his yard from the figure below, or to the right here, I'm sorry. Remember that we did add 3 feet, okay, to his yard. So we're not finding the area of 3x plus 2 and x. We're finding the area of x plus 6 and 3x plus 8, if you remember that. Okay, because it's already set up for it, this is a perfect opportunity for the area model. So we have x and 6, and we have 3x and 8. And if we use this as a times table, we end up with 3x squared. We have 18x. Okay, we have 48, and we have 8x. And we write that expression. That's how our answer is going to look. All right, the 18 and the 8 make a 26x and 48. That would be a polynomial expression for our answer.